Now, last time we have covered until hypothesis testing. Yeah, I think this is the last part that we discussed. That would be theoretically how we can perform the hypothesis testing. And since we are still talking about one sample, one sample for statistical inference, so we are going to settle the whole topic that involving the one sample, one population procedure. Okay, so let us begin with the hypothesis testing for single population mean. Now, I would like to just go back to the fundamental of statistical inference. Okay, so if you can see, we know that we are going to study our population. Okay, but since everything will be very expensive, limited time, limited human resources, so we are going to concentrate on our sample. So what happens is that we collect our data from our sample, and what we do with this particular measurement from our sample is that we are going to collect our measurement, and we are going to find the point estimate for each of the evidence that we have from the sample. And what we are going to do with this particular value of our x bar and p hat, we are going to do some, in this case, is what we call the hypothesis testing. Okay, since we would like to know what will be the population mean and population proportion, so what will be our evidence that we need to use is from our sample. And that's why we collect our data, and we find what will be the sample mean, what will be the proportion of a sample mean and sample proportion. And from these two values, okay, last time we talked about how we can find the point estimate. Okay, second, we can find the, since point estimate would be very difficult, since if we assume that this particular value is our sample mean, our population mean could be somewhere less or could be somewhere above. So what happens is that when we have this kind of doubt, we are going to do what we call our confidence interval. Okay, confidence interval. So that's why we are going to do some what we call measurement on how we can with certain confidence level, instead of having 1 point to estimate for your population for your statistical inference, we are going to enlarge our what we call coverage. Okay, so that whatever mu that we are expecting or we are assuming will be falls between somewhere of this particular interval. Now, that will be just for estimation only. But beyond that, which will be much more important, will be where we have to use our evidence to make a decision for our population. Okay, and this is what we call hypothesis testing. Hypothesis testing. Okay, and if you look at the name itself, okay, we are going to test, okay, several things, so that whatever we test, for example, using sample evidence of sample mean and sample proportion, we are going to make decision that our population mean would be this one, and population mean would be D1, and population proportion would be as what we are testing. Okay, so this will be the reason why we do such testing. Now, what is hypothesis testing? We have discussed that. Okay, and we know that from this hypothesis testing, it will involve two mutually exclusive statements. What kind of statement? Okay, that statement is what we call as the null statement and alternative statement. Whenever you heard about null hypothesis or null statement, alternative hypothesis or alternative statement, and that will be referring to these two particular things. Okay, the null hypothesis is the one that always written as H naught. H naught. Okay, and the alternative will be, sorry, typo error. So here would be what we call H1. Okay, H1. Okay, So what is the difference between H null and H1? Okay, H null is referring to a claim assumed to be true until sample evidence indicate otherwise. And for alternative is a claim to be supported based on sample evidence. Now the word that is important here is supported. Okay, and this one is assumed to be true until your evidence say that is not true, then only we say the evidence say against what we says or what we assume to be correct. Now, the one that I'm discussing earlier, this such as this one, is something what we call fundamental. Okay. Now I have discussed this in the last class, but I think I need to reaffirm again so that everyone understood. Okay, that our statement that are mutually exclusive, okay, can be written as this one in terms of symbol, where we have the null is equal to mu equal to mu naught. Alternative, mu not equal to mu naught. When you see this particular what we call notation, this refers to two-tailed test. Why? Because of the not equal to. If you are testing, okay, if you are testing that something is larger than your hypothesized value, larger than, so you are referring to the right of your distribution. So this is what we call right tail test. This is where the tail of your alpha. And left tail test usually refers to the statement of less than. And if you figure out all the null are the same, all are equal to, see, equal to, equal to, equal to. So the main thing whenever you have to do what we call hypothesis testing is you need to understand what will be the things that you need to test, whether it is not equal to or larger than or smaller than, and that will reflect the type of test that you are going to use. Okay, there will be times where this kind of statement can be rewritten, okay, in terms of words, okay, in terms of word, and this is what we call general words. Okay, if you are referring to the problem given to you, this one will reflect your given problems, the context of your given problem. So population mean is just what we call general terms in this particular example. Okay, so your statement could be in terms of symbol or in terms of what we call sentence. Okay, so equal to is equal, not equal, greater, less. Okay, so that will be some of the words given in the what we call the sentence of your hypothesis statement. And if you can see all the right hand side, the value here, all these value are what we call hypothesized population mean. Okay, so this value are given in from your question. Okay, given in your question. Now, what if I'm talking about proportion? Okay, as compared to mean, okay, I'm testing. You see, if you realize here, you are testing the population mean, and in order for you to decide whether this population mean is correct or not, you are going to use your sample mean. Okay, so this is what we call sample evidence. Okay, evidence that collected from your sample. And for the proportion, almost similar. It's just that we are changing all the mu with p, and the hypothesized value will be p naught. Okay, so that will be the hypothesized proportion value. And if you can see here, the null hypotheses are all still equal to. Okay, the difference one will be the alternative statement. Okay, so what about the claim that I said earlier on? What about the claim? Okay, this claim will be notified in your question. So you need to test what? Need to test what? So if it says the claim is at the null, okay, is at the null, then you are going to understand that this is your claim. Okay, we will see in the example afterwards. Okay, now as I mentioned earlier, okay, hypothesis testing for single proportion. So we will have three three approaches. The first one is traditional method, second one is p-value, and the third one is confidence interval. So this one relates to the last practice that we have covered last time. Now, what will be the steps in your traditional method? Okay, if you look at your textbook, your traditional method will be beginning at somewhere page 86. Okay. Uh, does any of your friend having problem to join the class? Because I need to admit all the what we call, okay, since the number is okay, so I believe because I have changed the setting. Okay, now let us begin with the traditional method. So for traditional method, there will be 5 steps only. Okay, the first one would be identify the claim of unknown parameter of interest and state the hypothesis statement. So here you see the plural word, so you need to note down what will be your H noun and H mark. And either one of them would be identified as your claim. Okay, and that statement will refer to your unknown parameter, whether it is referring to your mu or to your population proportion. What will be the second step? Find the critical value. What is the critical value? It's either your Z alpha or Z alpha over 2 if it is involving n larger or equal to 30. If it is less than 30, so you are going to reach your P distribution. So what is your critical value refers to? Here, what is your Z alpha over 2 and Z alpha refers to? If you are talking about two tail, so in this case, this is two tail test. Okay, two tail test means that you need to divide your alpha into 2. That's why you have alpha over 2. If you have what we call one tail test, for example, what we call, you are testing greater than, so you are testing this particular alpha. And if you are talking about left tail test, and that test will be referring to your critical value somewhere over here. Okay, so this is your alpha. Now, what else should you do? Then the next step will be computing your test statistic. So the one that I highlight in terms of capital letter, so that will be your keyword. So number 3 is test statistic. So test statistic can be using either Z or P. If here is using Z, then here using Z. If here is using P, then your test statistic will be using P. So it depends on the number of samples that you are testing. Okay. And step number 4, you make decision. Okay. What kind of decision? It depends on these two things. Your critical value and your test statistic. How? So if you are using your two-tail test, this is how you make your decision. If you are using your left tail test, this is your decision. And you're using your right tail test, this is your decision. How? Your alpha value is what we call the rejection region here. And the rest of the area is what we call non-rejection region. So do not reject now whenever your value is here. The same if you are talking about left tail test, okay, your alpha would be here. So this is your rejection region. And the rest of the area is the non-rejection region. So I would prefer to use non-rejection region. Okay, these three. Okay, how do I decide? Okay, if my Z, okay, this is referring to your Z alpha. This is referring to your Z alpha. Here negative, here Z alpha positive, here Z alpha. Okay, so if here is Z alpha over 2, Z alpha over 2. Okay, so we will show how later we can do the decision whether we reject or fail to reject. Easiest way, in simple way, if your what we call test statistic, your calculated test statistic using Z and P, if it is fall within the no-rejection region, then we say fail to reject null hypothesis. Okay. If you come and you got your test statistic is somewhere inside here, then you reject the null hypothesis. So that will be in theory how we are making the decision. And finally, of course, you are going to make your conclusion. Okay. So I believe you don't have any questions so far. Let us look at the things that you need to understand before we go to the first example. Okay. So this one is what we call the example of critical value. Where do we find critical value? In step 2. Where, how do we find the critical value? Is either we are using Z alpha over 2 or Z alpha or P. Okay, so in this case, this one is too small, Z. If this one is using Z. Okay, so this is left tail test, right tail test, and two tail test. And if you are using your alpha 0.05, then Z alpha, this one is Z alpha. So you will get negative 1.64, which is somewhere over here. Okay, if your alpha is 0.05 and you are doing your right tail test, then your Z alpha, okay, would be 1.64. And if you are using two tail test, then you need to divide your alpha here, divide by 2, which is 0.025. So that's why you get somewhere here and somewhere. So this is your Z alpha over 2. Okay, equal to 1 tail test. Okay, so that will be some basic of the critical value. And for the test statistic, I believe this one is given on page 87. Okay, page 87. Now, as usual, as what we have encountered in what we call confidence interval for one population mean, if you know whether your sigma is known, if you know your sigma, then you are using your sigma in your calculation. If you don't know your sigma, and then your n is greater than 30, then you are estimating your sigma using your standard deviation of your sample. If n less than 30, then remember to use your student T, okay, or T distribution. So this is for T distribution. Okay. Any questions so far, class? Any questions so far? No, huh? Are you all still with me?
Yes, no
okay.
question.
Okay, okay, thank you. Okay, now let's look at the first example, and you can find the example on page 87. Very simple. Now, how can we solve hypothesis testing questions? Okay, a sample of 50 internet shoppers was asked how much they spend per year on the internet. Okay, so here the first thing is your n is equal to 50. Okay, from this sample, mean expenses per year on the internet is RM 1,300. So we know that this is from the sample, so that this is your x bar equal to RM 1,300. Okay, and the sample standard deviation, clearly it is your S equal to RM 1100. Now, is there sufficient evidence to reject the claim? To reject the claim. So you can see the word claim here, that the mean yearly expenses is RM 1,500. Test at alpha 0.05. So you need to understand what will be your claim. This will be your claim. Okay, if I were to refer to your answer from your textbook, okay, so the first step, identify the claim. Okay, so if I rewrite again, so first, identify your claim. So we are using the population mean. So I know then mu naught is equal to, H naught is equal to mu equal to, this is your hypothesized value. So this is your mu naught. Okay, mu is equal to mu naught, that is 1500. Okay, and the alternative, now, how should I know this will be two tail or one tail? Now, what is the equation given to you? You need to test this statement. Okay, you need to test this statement. And along that statement, find the word that refers to the statement. Now, the statement is the claim that the mean of yearly expenses is. Then if you found is, then this refers to equal to. Okay, so equal to, where is equal to? It's in the null statement. So this is your claim. Okay, and definitely when you are testing equal to, the alternative become not equal to 1500. So if you have this, usually this will give you half mark here. Okay, now second. So the first step, you got your statement and you got your claim. Okay, you identify your claim. Second, what will be the second one? Critical value. Okay, so critical value refers to since your condition n greater than 30. Okay, now we know we are referring to the to n greater than or equal to 30. Then what else? Should sigma known? In this case, sigma is unknown. Okay, so these are among the things that you need to identify first. So critical value is your Z. In this case, you are talking about two tail test, then you have Z alpha over 2. So your alpha is equal to 0.05. So Z 0.05 divided by 2 would be Z 0.025. Okay, so for Z 0.025, just in case any one of you forgot where to find, so 0.025. Okay, for alpha 0.025. So this is your value 1.69. Okay, so you will get 1.96. Sorry. Now, knowing that this is a two-tail test, then you put your plus minus sign because you are referring to the n tails, the left tail and the right tail. So this one must be note down. Otherwise, if you just put what we call 1.96, you will get wrong. Okay, so please make sure that you take into consideration what kind of test that you are testing. Now, number 3. Okay, number 3, find the test statistic. Okay, test statistic. Now, since since you are you got your critical value using your Z, okay, definitely you are using your Z for your test statistic. So the word statistic will be without S. So in this case, your test statistic is your Z, which is obtained by X bar minus your hypothesized value of your population mean and divided by estimated by using your sample standard deviation divided by square root of n. So Z is equal to 1300 minus 1500, that is your statement here, divided by 1100 divided by square root of 50. So if you calculate, you got here negative 1.286. Okay, now making decision, the third step. Okay, making decision. How do I make a decision? Okay, so your decision would be using the two numbers that you got in your second and third step. Okay, so what happened? You know, begin with your Z alpha, your critical value. Okay, Where is my Z alpha? Z alpha over 2. Let's say this is my Z alpha over 2. That is negative Z alpha over 2. Here is Z alpha over 2 positive. That is given by 1.96. Here is negative 1.96. So this is the alpha over 2. And this is your alpha over 2. Now, what is my test statistic? Okay, done with my critical value. My test statistic, I got negative 1.286. Now, find where is the location of your Z. Where is Z? Z is along this line. Okay, negative 1.2, which is larger than negative 1.696, sorry. So let's say the line for your, this one is, let's say this one. Okay, since we are talking about non-rejection region here, these one are all non-rejection region. Okay, so what is my decision? Then here, since this falls in non-rejection region, we say fail to reject null hypothesis. Remember, decision will always reflect your null hypothesis. Your null hypothesis, that is this one. Not because of the claim, your decision must always reflect your H null. Okay, not H1. If you say accept H1, then it is wrong. Or it must be null hypothesis. Okay. And finally, how do I make my decision? Okay. And this one I would like to refer directly from the answer. Okay. There is, remember why we should remember that our claim is null hypothesis mu is equal to 1500. And this is our claim. Now, what we do with this claim, we fail to reject. Okay, so what will be our interpretation or our conclusion? There is insufficient or not enough evidence, okay, to reject the claim that the internet shoppers spend 1,500 per year on the internet at 5 significant level. This one is optional. You can put or you cannot. If you don't want to put, it's okay. As long as you interpret your decision. Okay. So for any question, class? Any question, class?
No question.
Okay, no question. Then let's see. Let's say we change the equations because I need to show you what will be the difference between two tail tests and one tail test for the right and left tail. Now, if let's say I'm using the same exact example, but then I change the last sentence. Okay. So for the second example, using the same exact example, I change the claim. Okay. Is there sufficient evidence to reject the claim that the mean yearly expenses is less than? Okay, is less than. So we are talking about this particular, what we call okay, this particular, okay, now, okay, let me do it very quick. Okay, the first one, the statement, so it will be null, mu is equal to, you are testing 1,500. Okay, now, did I change? Oh no, I didn't change. Okay, I'm still using the hypothesized value is 1,500. So I have 1,500. Okay, and the alternative is mu, since the claim is less than. Okay, so mu is less than 1,500 and this will be my claim. Second, critical value. Okay, critical value, we are referring to Z alpha. In this case, Z alpha is Z 0.05. What is Z 0.05? So if we check for our what we call Z 0.05, you will get 1.6449. Okay, 1.6449. Okay, it would be 1.6449. Now, since this is a left tail test, you are going to put your negative value here. Automatically, it becomes negative because we are talking about what we call left tail test. Okay, so remember here, class. Okay, whenever you are testing for a what we call left tail test, your Z alpha definitely become negative value. Now, third step. Third, your test statistic. Okay, your test statistic in this case still Z because N is 50. So Z is equal to, just put everything together. So X bar is 1300 minus 1500 divided by estimation from the sample is 1100 divided by square root of 50. Can someone calculate this? What did you get? 1300 minus 1500 divided by 1100 divided by square root of 50. What did you get here, class? The same, right? One negative, the one that we got earlier on, right? 1.286. Okay. So the fourth step would be making decision. Are you all with me? So quiet, everyone.
Yes, okay.
Okay, thank you. Now you have your making decision. Okay, left tail test. So for example, if you are talking about negative, your critical value is 1.6449. So let's say this is your negative 1.6449, which is your Z alpha. Okay, so this is your rejection region. Okay, and you got your what we call test statistic is 1.28 negative. So 1.28. So for example, this is your location of your Z equal to 1 negative 1.286. Okay, so we know that this is non-rejection region. Okay, so in this case, fail to reject null hypothesis since the test statistic fall in the non-rejection region. So if you are being asked about why, then you can say the Z or the test statistic falls in the non-rejection region, or you can say the Z test, which is negative 1.286, is greater than Z alpha negative. That is negative 1.6449. This could be your reason. Or secondly, you can say because Z test falls in the non-rejection region. So there will be a reason. Sometimes we may ask why. Okay, so this can be your reason. Sorry. Okay. Now, what will be your interpretation? Okay, number 5. Okay, so here you can say, since we know that our claim is at the alternative, yet we fail to reject. So what will be your conclusion? Now you need to be very careful, class. Okay, so since our claim is at the alternative, okay, so we can conclude that there is insufficient evidence in this case is to support. Just now, we have insufficient evidence to reject. Okay, our claim is at the null, and yet we fail to reject null, so we have insufficient evidence to reject. Okay, Now here the claim is at the alternative, and we fail to reject this. Fail to reject this means we have, because we need to prove this. So that's why we say there is insufficient evidence to support our claim that the internet shoppers spend less than RM 1,500 per year on the internet. Okay. Now, any questions so far, class? That would be the first what we call comparison. If you are using the same exact question and just we change the claim and we are using the left tail test. Okay, earlier on is two tail test. Now, what if I'm testing for the right tail test? And of course, for the right tail test, I need to adjust the value of the hypothesized value, that is your mu naught, so that I can get positive value, okay, to the right hand side of your upper tail table. Now, is everyone okay, class?
Okay, madam.
Okay, huh?
Okay,
Okay.
madam.
Now, if the null hypothesis, then the question is there sufficient evidence to reject the claim that the mean of yearly expenses is more than. Okay. So as usual, the null will always be equal to 1,000. Okay. And the alternative would be mu less than 1,000. And this is the claim. Okay, the question is kind of wrong. Here is not to reject, is to support. Okay, is to support. Here also less than is to support. Okay, now we know then our claim, we got the statement, we got the claim. Second, Z, find the the critical value. Second is the critical value, right? Yeah, critical value. Z alpha, given that alpha is 0.05, and you know 0.05, you get 1.96. Third, test statistic. Okay, and we know that Z is equal to 1,300 minus the hypothesized value is 1,000 divided by 1,100 divided by square root of 50. So can someone what we call calculate? 1,300 minus 1,000 divided by 1,100 divided by square root of 50. Did you get this? 1.928. Okay. So if I got wrong, let me know. So number 4, decision. Okay. Now we know that decision will involve 2 and 3. So draw your rejection region and non-rejection region. And we know we are talking about the right tail test. Our critical value is 1.96. Okay. Is it correct? I would like to have the test to be rejected. 1.92, 1.96 is almost feel like I fail to reject. Fail to reject because this is my alpha. Okay, Z alpha equal to 1.96. Z alpha is equal to 1.96, right? 0.05. 1.6449, sorry. No one is correcting me. Are you all with me or are you studying, class? 1.6449. So here is 1.6449. Okay, now I need to check the location of my test statistic, and test statistic is 1.93. So we know that 1.93 is somewhere, let's say over here. This is Z test, okay, which is 1.93. Okay, so we know that this is rejection region. Okay, what happened? What would be my decision? My decision would be reject null hypothesis. Why? Because Z test is greater than Z alpha. Okay, that is Z test 1.93 and Z alpha is 1.64, for example. Okay, if you are being asked about the reason. And how do I conclude? Okay, my conclusion will be, since my claim is at the alternative, okay, yet I reject null. Okay, reject null hypothesis means that I have enough evidence. Because I reject null, so I can support my claim. So that's why this becomes, therefore, we have sufficient evidence, okay, sufficient evidence to support our claim that the internet shoppers, okay, spend more than, the hypothesized value is 1000, so 1000 spend more than RM, okay, RM 1500 per year on the internet. Okay, so that will be the difference between if I test for right tail test, left tail test, and two tail test. Okay, so far okay, class? Okay, yeah?
Madam,
Okay.
Yes. Yes, any question?
nak tanya dekat step pertama tu yang H1 tu, simbol dia bukan modern ke?
So, Allah Akbar. More than, yes. Tapi silap kat situ je lah kan. Okay, thank you. It should be more than. Okay, thank you
Okay,
for
madam.
correcting me. It should be more than. Sebab dia right tail test. Okay, thank you. The rest I don't think any mistake lah so far, hopefully. Any other comment? If I didn't see? Okay, so if okay, then I need to show you how this tree can be carried out using p-value method, which is much simpler actually. Okay, but you need to understand, if you need to understand the p-value, you need to understand this first. Okay, because once you have understood this, then p-value would be very easy. Okay, now what is the difference between the traditional method and p-value method? And it involves only at the middle part. Okay, find the test statistic Z or T, compute p-value using test statistic. Compute p-value, your p-value is actually using your test statistic in the step 2. Okay, and then making decision is almost the same. It's just that it will be referring to, so this one is referring to the probability value. Okay, which means you are going to use your alpha and the other probability. Alpha versus, I would say easier, versus probability of your test statistic. How? I'm going to show you after. Okay. So step 4, making decision by comparing alpha and the probability obtained by your test statistic. Okay. Now let us look at the first example. Okay. The first example. Okay. The first example. Let's say we have the statement. Okay. Let me change the pen. Okay. We have the first statement done. Second, you need to find, what was the second step? Compute the, find the test statistic. Okay, knowing that we are using Z, so Z will be 1300 minus 1500 divided by 1100 divided by square root of 50. And this is given by, what was the value? Negative, okay, negative 1.29. 289, 286. Okay. Now, what this refers to, class, you are going to identify. This will give you what is the probability given by this value. Okay. We know that this is Z. Okay. How? Because we know if I draw the standard normal, okay, where is this located? This is referring to Z. So Z, where is Z? Z is, let's say, somewhere over here. What is the value here? Is negative 1.286. I need to know what is the value of this probability. Okay, remember we have learned this in the earlier chapter. If I were to find this, since this is a symmetric distribution, we know the middle is equal to 0. We bring to this part, this will be 1.286, which is this part. And of course, I can use my first Z standard normal table by finding this. What is the P of Z is between 0 until 1.286. Let us see. Remember 1.286. Let's check our first table of standard normal. Okay, this is second table. We refer to first table. Now, because we know we are referring to Z equal to, here Z is equal to 1.286. So look for, since we are talking about 2 decimal point, then let's say we only say 1.29. So look for 1.29. So the value is 0.4015. Okay, remember 0.4015. 0.4015. Then we know that this one is given by, let's say I use another pen. This one is 0. Here is, I'll just write inside. 0.40, what was the value just now? 4015.
415.
If this is, okay, thank you. Okay, so if this is 4015, then I know this is 0.5 minus, let's say another color lah, so that it will be easy for you to observe. Okay, and let's say this is purple. Okay, so here 0.5 minus 0.4015, I will get 0.0985. 0.0985. Okay. Now, because since we are talking about two-tailed test, this is a two-tailed test. So remember, this is a two-tailed test. Two-tailed test, a bit different to one-tailed test. I should go for one tail test. But since I just coincidentally did the two tail test, then we proceed. Okay, now we know then the probability of this shaded area is 0.0985. Remember. Okay, now we continue with the third step. The third step says you need to compute your p-value. Okay, what is my p-value? Okay, my p-value. Okay, third, compute p-value. My p-value is based on Z in step 2, which is you have obtained this one. Okay, from your Z test statistic, from your test statistic, we find what will be the probability given by your what we call test statistic. Now we have obtained your test statistic, but now since this is a two-tailed test, okay, since this is a two-tailed test, let me check your textbook. Okay, in step 3. Okay, it is in step 3. Now, since this is a two-tailed test, for two-tailed test, your p-value will be multiplied by 2. So, here you have 2 multiplied by 0.0985, you will get in your textbook, okay, 0.197. Okay, so this is a two-tail, the p-value for two-tail test. Okay. Now, the fourth step. Okay, this is where you make decision. How to make decision is based on step 2 and step 3. So number 4, make decision. Simple je. Make decision. Since two-tail test, I don't want to what we call confuse you. We just make a decision this way. If alpha is greater than your p-value, do I use the same? Okay, if your p-value greater than alpha, okay, if I need to follow the textbook so that you can easily follow. Okay, if p-value greater than your alpha, then we say we reject now. We is greater than. If let me read this way. If one tail test, it will be easier. If p-value less than alpha, then reject now. Okay. Now check. Okay. Check. What will be our decision? What will be our alpha? Our alpha is 0.05. Okay. And our what we call probability value here is 0.197. So it is greater than. So since it is greater than, okay, since okay, p-value is greater than alpha, then fail to reject null hypothesis. Okay, so number 5 follow as usual, as above. Okay, if you don't understand, it's okay. Okay, because some of you may take time to digest and understand the whole concept of p-value. Let me bring you to the second example. If we have one tail test, which is much simpler and can be what we call described by using this particular distribution. Okay, now this is for left tail test. Okay, so for left tail test, okay, let's say dot follow above it, and then we know for the what we call second step is finding your test statistic. Okay, So test statistic in this case is Z equal to 1300 minus the hypothesized value is 1500, okay, divided by is this the same? I should only take the answer. Okay, here we got negative 1.2856. Okay, the same, right? The same as just now. Okay, and we know that. Okay, we know that. So this is left tail test. So we know that this is the Z alpha that is negative. Sorry, not Z alpha. Z only, yeah. Z negative equal to negative 1.2856, which is this area. And we know that the probability here, which is number 3, find p-value, okay, by using the p-value of your Z equal to negative 1.2856, okay, as this one is equal to the one that we got just now is 0.0985, 0.0985, 0.0985. Okay, now number 4, where is this? This is given by this. Okay, this is given by this. Oh, it's so bad. Okay, we do again. Okay. This is this one. Okay. Now, what is my alpha? A decision here. Decision. My alpha is 0.05. Okay. If this is 0.0985, okay, we make decision if p-value less than alpha. So this is your p-value. So this is your p-value. Okay. Your alpha is 0.05 and your p-value, okay, if p-value less than alpha, okay, we check now. Now, my p-value is 0. P-value is 0.0985. Okay, and my alpha is 0.05. Okay, so what happened? It is larger than alpha. So here, fail to reject. Okay, so fail to reject H now. So number 5, conclusion as above. Okay, so this is one way on how to see in terms of one-tail test. Now, in the case of what we call, where is the location of alpha actually? Okay, where is the location of alpha? If I were to, since this is one-tail test, it will be easier for me because I need to just focus on the left tail test here. Now, what is Z alpha over 0.05 plus? If Z 0.05 is what is the value? Plus Z 0.05 just now. Here, right? Negative, right? Negative 1.6449, right? So if I were to check for Z alpha 0.05, I will get 1.6449. Just to show you, it is in the rejection region. So where is my negative 1.664? So much smaller than 1.2 negative. So let's say this is where negative 1.6449, and this is my alpha value. Okay, and this is my rejection region. Okay, if I were to rewrite this, okay, this is my rejection region. Okay, so you can see that this is your alpha. Okay, your alpha. And this is the non-rejection region. Okay, so that's why we fail to reject, because our probability, our p-value is larger, and we are not in the rejection region, we are still in the non-rejection region. If your p-value, okay, if your p-value somewhere, let's say I take the yellow pen, somewhere over here, okay, which is very small, smaller than your what we call alpha, that is 0.05. Okay, so you will reject the null hypothesis. But since it is in the non-rejection region, then that's why we feel to reject null. Let's look at if we are using the right tail test. Okay, so for the right tail test, okay, step number 2, okay, Z test equal to, because we are testing for this one, so Z, sorry, test statistic, yeah, I will write test statistic first. Test statistic, okay, equal to Z x bar 1300 minus 1000, okay, because this 1000, more than, did I change? More than should be here. Sorry, this is the, I forgot to change. So this one is actually 1500, 1000. Sorry. Okay, I choose 1000 because I need to make it positive. So divided by 1100 divided by 50 square root. So here I will get 1.928. Okay, as I mentioned earlier. So this will be a hint for your p-value. So third, p-value. Okay, so how do I find my p-value? Okay, so I have test statistic, that is my Z here, Z equal to 1.9285. Okay, since I need to know what is this, so I use my first table, okay, which is Z equal to 0, and I need to find what is the probability here, that is for Z from 0 until 1.93. Okay, so 0 until 1.93. Look again for 1.93. Okay, 1.93. Okay, 1.93. I'm correct, right? Test statistic 1300 divided by minus 1000, the hypothesized value. This is your mu naught. Okay. Okay, so 1.93. To look for 1.93, 1.93, 1.93, 1.9.
0.4726.
Okay, 0.4732. 32, right?
32.
32. Okay, 4732. 4732. So here is 0. Here is 0.4732. Here. Okay, so here will be 0.5 minus 0.4732. So that would be equal to
0.0268.
0.0268. Okay, now we got our p-value. So this is our p-value. Okay, we need to check with our alpha. Our alpha is 0.05. Okay, so if I were to write it directly, okay, what is my, okay, my 4 is decision, decision. Okay, let's say I just use my figure here, Okay, how do I make decision? Okay, now compare between alpha equal to 0.05 and your p-value is equal to 0.0268. Which area is bigger, 0.05 or 0.0268? This is larger, right?
0.05, yeah.
Yes, so what happened is that you can imagine the area, the alpha will be a bit larger. For example, if I sketch, this is my alpha. And we know that this is rejection region. Okay, so then we know that since p-value, okay, p-value is smaller than your alpha, which is, if you put the value 0.0268 is less than your alpha is 0.05. That's why we reject null hypothesis, because obviously the p-value is smaller and it falls within the rejection region. So that's why we reject the null hypothesis and we make the conclusion as what we have decided above. Okay, so number 5 as above. Okay, so I think I have